Today we are talking about, I have it abbreviated on the board, but I'm going to write it out the long way here. Applications of differential equations. We are going to be looking at where we use differential equations in the real world, and we're only scratching the surface of this because of our limited knowledge of what differential equations are, okay? Something that you did in pre-cal came from differential equations, so we're going to revisit that topic, but we're going to tie in the differential equation component to it, okay? We're going to be talking about many different things and many different uses of this, not as much in the notes, more so in the homework problems. The notes questions are not quite as big as far as going into the detail for the real world, partially because I don't want to sit there and write it all down. So we have to start out with a little bit of review before we can jump into this. So we're going to review some terminology. First of all, y is directly proportional to x. You did this in Algebra 2 and in pre-cal.
Is that in all cases?
In all cases. So, y is directly proportional to x. Do you guys remember direct variation, inverse variation? Does that sound vaguely familiar? Vaguely familiar? Okay. The equation that is direct variation has an x and a y in it because it talks about x and y. It also has a k in it. Does anybody happen to remember what it is? I'll turn it into a multiple choice question. Is it k times x or k divided by x? K times x for direct variation. Direct variation is a situation where as x gets bigger, y gets bigger. For example, if 2 pounds of apples cost $2.50, how much does 10 pounds of apples cost? Will the cost be more? Yes, definitely. Because as you raise the apple poundage, you raise the cost. Okay? I'm using different colors just for emphasis. You don't need to. The second one, y is inversely proportional to x. So if directly is k times x, what do you think inversely would be? K divided by x. Inversely proportional is this kind of situation. As x gets bigger, y gets smaller. So listen to this question. I actually want you to answer this one. If it takes 6 employees, let's say 10 hours, to mow a golf course, how long would it take 3 employees? Okay, if it took 6 employees 10 hours, it would take 3 employees 20 hours. As the hours goes up, they do the opposite direction. That's inversely proportional. Okay? Now, those are Algebra 2 pre-cal level questions. Here is a calculus level question, and you're going to have to be doing some of these yourself today. Please write this down. The rate of change of y is proportional to y. That's kind of strange. Okay, the rate of change of y is proportional to y. Now, this one is missing a few things. Usually it'll tell you the rate of change of y with respect to whatever. And it also doesn't specify direct or inverse. But let me tell you this. I'm going to add in, just out to the side, the rate of change of y with respect to time is directly proportional to y. If it doesn't say directly or inversely, it's understood to be directly. So, how do you write the rate of change of y with respect to time? How do you write that? dy over dt, exactly, equals. Directly proportional is k times y. Okay? Now, look at that. Right there that I just wrote down. That right there is a differential equation. Okay? That is a differential equation. It's a variation problem, the foundation of many, many problems that you do in pre-calc. It comes from this relationship. The rate of change of something y is proportional to that something. Okay? So we're going to do a sample problem that deals with this. Please write this down. The rate of change of y is proportional to y. I know I'm being redundant, but bear with me. When t equals 0, y equals 2, and when t equals 2, y equals 4. Oh, wait just a second. The rate of change of y is proportional to y. When t equals 0, y equals 2. And when t equals 2, y equals 4. The question is, find y when t equals 3. Looks like findy. Find y when t equals 3. Okay, if the first sentence wasn't there, when t equals 0, y equals 2. When t equals 2, y equals 4. What would you guess when t equals 3, what would y be?
6.
You could do 6 or possibly 5. Okay, but that's honestly too easy. Is that a calculus level question? No. No, that's not a calculus. It's like SAT questions, especially if you get to the end of the SAT and you're getting those last few questions. If they look really, really easy, they're not, because they always put the hard ones last. So, anyway. We are going to take these problems. They're going to give us a sentence that makes us create a problem like this. This sentence matches this sentence. So we just copy down dy dt equals k times y. And from this, we are going to create a general solution and then use this other data to find the specific solution and then the answer to our problem. Okay? Now, I need to solve for the general solution, which means I need to separate the variables. So think back to last week. What's the first step in separating the variables? Move over what first? dt moves first every time. Whatever's on the bottom moves first. Now what else needs to move? Y does. So move the y, move the y. So now I have dy over y equals, the y's on the right are gone, k dt. What's the next step? You guys need to know this. Integral on both sides. Exactly. What does the left side integrate to be? Natural log of y. Now, as I walked around helping people with the worksheets, I discovered that several of you are getting sloppy and dropping those absolute values. They have to be here. They will take points off on the AP exam if you don't put them. So get in the habit of doing so. Okay. This side right here, the k is a constant, so it can come out. And what is the integral of a dt? Just a t plus c. Okay? Now, I need to solve for y. What do I do? E both sides. Raise both sides to the power of e. Now you can take off the absolute values on the y. The right side says e to the kt times e to the c. You break it apart this way. This is the way we did it before. So now we have y equals c e to the kt. Do you remember doing this question last week?
Yes.
Okay. This right here is the law of exponential growth and decay. It is the law of exponential growth and decay. Now, what determines growth or decay? The value of k does. If k is positive, it's growing. If k is negative, it's decaying. You did lots of problems dealing with this in pre-calc. dealing with bacteria growth or population growth or half-life of a radioactive substance, okay? And it all started with a differential equation. They didn't tell you the differential equation pre-calc, you didn't know what they were. But that's where they started. That's where these came from. That's where that formula came from. Okay? The problem is pre-calc. It's all just solving equations. Okay? So now we have a situation, E is a constant, C and K are both constants. We need to solve for both of those. And what we use is this data that they gave us in the problem. So what I'm going to do now is come over here and I'm going to start with the one where t equals 0. T equals 0 is the easiest one to start with because it always makes k go away. So I'm going to write the coordinates 0, 2. I'm going to take this equation, plug them in for t and for y, and solve for one of the variables. So 2 equals c e k times 0. So 2 equals c times e to the 0 power. And e to the 0 is what? 1. So that goes away. So now I know that c is 2. So 1 down, 1 to go. I found c. Now, go back to the regular general solution, put in the value you found for c. So now we have y equals 2 e to the k t. Now with the homework you just turned in, that's where you would stop. We're going farther. We're going to actually find k now for this problem. And we're going to use the other point they gave us, the 2, 4, to find k. So I'm going to write that point down, 2, 4, and I'm going to plug it into this formula, and now all I'm going to have left is k to solve for. So 4 equals 2 e k times 2. Now, this is pre-calc, folks. So we got to think back. What do you think we need to do first to solve for k? Divide by 2. Now, do as much mental math as you can. You don't necessarily have to write divide by 2, divide by 2. You can just go straight to the answer. 2 equals e to the 2k. Just write enough that I can follow what you're thinking. Now what do? We have to natural log both sides to bring the 2k down. So the natural log of 2 equals the natural log of e to the 2k. I left a little space because what I'm going to do is I'm going to take that 2k and move it to the front. And what does the natural log of e equal?
1.
1. That's gone. So now I have ln of 2 equals 2k. So k will be that divided by 2. And take my calculator. Thank you. Now, this is very important that you follow along with me on this part. I'm trying to get it out of the glare. You need to type in ln of 2. Make sure you close that parentheses, divided by 2, and you're going to get a decimal. 0.346 dot dot dot. Now, you need all of those decimals. So what I want you to do is store it for k. And if you write it on your AP exam that you are storing it for k, from this point forward, you can write a capital K in place of that decimal in all of your work. So I'm going to push the store key, which is above the on key if you don't remember, left parentheses. So push the green alpha key and then the left parentheses. There's your K. So there it is, stored in there. Okay. Now, I need to move back up here because I ran out of room. Now I'm going to write my formula with my C and my K in there. So it's going to be 2e to the capital KT. I'm changing to capital K because that's what it's stored for in the calculator. All right. Now I need to slide the paper down because I need to look at what the question asks. That's just getting to the step where I need to solve it. Now this is the last step is short. Find y when t equals 3. So all I have to do now is, so for t equals 3, putting that into parentheses, y equals 2e capital K times 3, and that's what you type in the calculator. Move it over here. 2e capital K times 3, and I get 5 point, how many decimals am I supposed to go? 3. At least 3. 6, 5. You can chop it off with a 6 or you can round it to a 7. It does not matter. Or you could go out 4 or 5 decimal places just to be safe. Questions? Okay, let's kind of recap what we did. Lots of work here. First of all, it gave us the rate of change sentence, which wrote down that formula right there, dy dt equals k times y. We separated the variables to get the general solution. Then we took the data, the 0, 2 to find the c. We took the 2, 4 to find the k. Then we wrote our equation, plugged in the 3, and got our answer. So, sometimes these will be... I'm about to give you one that's a little bit shorter. But do you have any questions on this one right here? Anybody? All right. I need to change papers. Is everybody done writing? Okay. Now, next problem. Let's talk about fruit flies. Yay, fruit flies. We love them. No, we don't. A fruit fly population. Can you read what I'm writing? Yes. Increases according to the law of exponential growth. Now I'm going to summarize the rest of it. There were 100 flies on the second day. There were 300 flies on the fourth day. The question is, how many were in the initial population?
First day?
That's the question I want to ask you. Okay, finish copying down, and then we'll discuss that.
You write so fast.
I know, because I know what I'm going to write. That's why I'm waiting for you. Here's the question. Initial population, is that day 1 or day 0?
0. That's day.
It happens to be day 0. Because, for example, in physics, when they say initial velocity, that's the velocity at time 0. Initial means day 0. Okay. Now, here is the nice little thing that's going to shorten our work. Because it says this sentence right there, or that phrase, the law of exponential growth, I got an equation for that right there. So I can jump right to here. I don't have to do all this. But I can only do that if it mentions the law of exponential growth. So we have y equals CEKT. Ready to go. Now, listen carefully. Because I don't have t equals 0, I can't get the k to go away. So what I have to do is some very creative math. I did teach this in GT a couple years ago, so those of you who were in my class may see it again, but I'm going to show the rest of you because it's really neat. I need to plug both ordered pairs in immediately, and I'm going to solve the system by some unusual elimination. Okay? When you guys did systems of equations, grab this paper. Systems to you guys is like x plus 3y equals 11 and 2x minus 5y equals negative 4. You remember that? Okay? We're going to create two systems that do not look like this, but they can be solved in a kind of similar way. Now here's what you're going to do. I need you to take, and I want you to plug the second equation in first. Okay? Which number is y and which number is t? 300 is y. This is time. So we write 300 equals c e to the k times 4. And then we write 100 for the other equation equals c e to the k times 2. I'll tell you later why I did the second equation first, but for now just do what I'm saying. All right. The problem I showed you a second ago, that systems of equations, you used to do elimination where you multiply a line by something and then you add them together, okay? But would adding these two together gets rid of either the c or the k? Not in this case. I can do another operation to these two to make a letter go away. Does anybody know what? Trey, tell me. If I divide these two, won't the c's cancel out? Yes. So what I'm going to do is I'm actually going to divide those two equations right there. What is 300 divided by 100? 3. The reason I put the second one first was because I wanted the bigger number on top when I divided. Equals, the c's cross out. So I have e to the 4k divided by e to the 2k. What should I do to the exponents? Subtract them. What's 4k minus 2k? 2k. So this is e to the 2k. Now I can solve that. What do I do now? ln both sides. Natural log of 3 equals, I'm going to bring down the 2 at k right off the bat. Natural log of e is 1. Divide both sides by 2. I want you to do that in the calculator for the new k. So clear that out. ln of 3 divided by 2. And this is what I forgot to do last period, was store this for k. Okay? So this is 0.549 dot dot dot. And I'm going to write STO arrow K, capital K. So now I know K, but I don't know C. How do I find C? What do I do with this? Plug it into one of the two equations that I made. So let's take the second one. So I have 100 equals C, E, capital K times 2. Solve for C. What do I do? Divide by e to the 2k. E to the 2k. Those two cross out. Now I can find C. So, can you see that? Good. 100 divided by e to the 2k. And I get 33 point, oh nice repeating decimal. I don't have to write 3 decimal places. 33.333333. My equation is now y equals 33.3 repeating e to the 2, wait, k t. It's not 2 anymore because I took out the 100. That is my solution. We're finding the equation. Then we have to use the equation to answer this question. How many were in the initial population?
So we're just doing the 2 sub-columns.
Correct. Correct. So now, to find day 0, I'm plugging in 0 for what? T. So t equals 0 would be y equals 33.3 repeating e to the k times 0. So what does y equal? 33.3 repeating. The thing is, though, that's not the correct answer. Who knows what the correct answer is?
Flies.
It's flies. So what should it be? You could, okay, now people have argued both ways. You can say either 33 or 34, and the AP exam would count it right. Because some people argue, well, it's a 0.3, so it should round down. But some people say, well, you've got more than 33, so it should round up.
So they could be like mutated.
Yeah, they could be. What do you think it should be, 33 or 34? Okay, I think it should be 33. That's my opinion. Okay. So, there are 33 flies in the initial population. Okay? Questions?
It's just a lot of work.
It is a lot of work. That's why you're not going to have too many problems to do. Okay? All right. I know that says a lot, but that's not all those work. Okay. Now it's time to talk about CSI. Okay. How many of you in this class watch CSI or Law and Order or some shows like those? Do any of you like those shows? I love those shows. Law and Order. Okay. Isaac Newton, in his infinite wisdom, designed a formula, a differential equation, that allows the scientists to determine how long a murder victim has been dead at the scene of a crime. That is calculus. Okay? Now, let's say that 2 murders occurred at exactly the same time. Listen to my scenario. Okay, 2 CSI teams are sent to 2 different parts of the city. Team 1 goes to this mansion. Okay, goes to this mansion. They go in the mansion. They find the old rich guy on the floor, dead of a heart attack. Okay? They suspect it might be foul play, but they're not sure. Okay? They check him using this formula that I'm about to show you, determine how long he's been dead. Based on, what do you think? What are they?
Temperature.
The temperature of the person, right? Because once your heart stops beating, your body starts cooling. And what is the lowest that your body temperature will go down to? Whatever the temperature is where you are. If you're in a room with the heat on, you're going to go no lower than that. Does that make sense? Okay. CSI Team 2 is sent out to the bad part of town where they find this old homeless guy, unfortunately, who has died of a heart attack, living in his box in the snow. Okay? Whose body temperature would you believe, if they both died at the same time, would be lower? The homeless man. Because of the fact that he is outside compared to the guy who was in his house. Okay? So, there are many factors affecting how long it takes a specific object to cool. First of all, what it is, in this case a human body, and where it is. Is it in the snow? Is it in a house? Is it sitting on the counter in your kitchen? Is it your pizza you just took out of the oven? Or did you set it outside in the 40-degree temperature because you wanted it to cool faster? Have you ever taken a cup of soup and it's so hot you stick it in the freezer for about 2 minutes to cool it down? Yeah, because it cools faster. Okay? So, this is called Newton's Law of Cooling. So please write this down. Newton's Law of Cooling. And it looks like I'm going to have to change colors because my purple is dying. Time to go to blue. Purple is dead. Okay, here we go. Here is Newton's Law, and we're going to use it to write a formula in a minute. It is the rate of change of the temperature of an object. The rate of change of the temperature of an object. I'll wait for you on that. Is directly proportional to the difference between the object's temperature and the temperature of the surrounding medium. That's the official definition. I'll wait for you to catch up with me. The rate of change of the temperature of an object is directly proportional to the difference between the object's temperature and the temperature of the surrounding medium. Okay, we are going to do a Newton's Law of Cooling question, talking about a generic object. The ones in your homework are going to talk about, for example, pulling out a pie from the oven. You've ever burned your tongue on hot food out of the oven? It's so frustrating. But there's actually a way to mathematically calculate how long you got to wait till it's cool enough to eat. Do you really want to do that? Nah, I'll just take a bite and check and see. But which would cool faster, do you think, a pie or a pizza?
Pizza.
I know a pizza's a pie. A pizza would, because it's not as dense. Pies take a long time to cool because they're. Okay, yeah, that's true. Okay. All right. I need this law in order to do the problem that I'm about to write down. Example. We got to hurry because I think I can get it done.
Is this long or is it pretty short?
It's pretty long. No, you need to go new sheet of paper. Okay. Here we go. Y represents the temperature of an object in a 60-degree room. Suppose that the object cools from 100 degrees to 90 degrees in 10 minutes. That's pretty quick. How much longer until it reaches 80 degrees? Question mark. I'll wait for you now. I'm thinking in the future I may have this stuff printed up because it takes so long to write it down.
Is this Celsius?
Did I have a question? I'm sorry.
How do I see what Celsius is?
Still didn't. Okay. This one is going to be kind of long like the first one because you've got to come up with the general solution. We don't have one yet. Okay? Now, look up here. Is everybody done writing? No? Yes? I'll wait just a second then. Okay, we're going to use the Newton's law to come up with our differential equation we need. Okay, it says the rate of change of the temperature of an object, and it says that's supposed to be y. So how do we write the rate of change of y? dy dt equals. It says directly proportional. So is that k times or k divided by? K times. The difference, now listen carefully, what is difference in math? Subtraction. So I'm supposed to subtract the object's temperature, which is y, from the surrounding medium. What does it tell me in this problem the surroundings are? What temperature? 60 degrees. So k times all of that. Now I don't need this anymore. Now I need to separate the variables on this one. Okay, tell me what to do first. Move dt over. What else needs to move? Y minus 60. So we have dy over y minus 60 equals k dt. Okay, the right side's looking familiar. Next, integrate both sides. Now, do you think that this might be an ln again, like it was last time? What's the power of that whole denominator? 1. Did I tell you if the power is 1, it's always a natural log? Yes. So, the only thing you really need to do is take the bottom and take its derivative and make sure there's no numbers in there. What is the derivative of a y? dy. Well, if you don't have to worry about a dy, what is it? Just 1, right? If it's just a 1, you're good to go. You can just say that's going to be ln. So we're going to say ln absolute value y minus 60 equals, what's the right side going to say? Kt plus c. Same as last time. What's next? E on both sides. So y minus 60, you can take off the absolute value bars. E to the kt times e to the c. There's the c. Y minus 60 equals ce kt. Now it looks almost the same except for that 60 in there. So move the 60 over. So it's ce to the kt plus 60. So very similar to the other one, just throws in the number. Okay, put a big star by that because we're going to need to come back to it later. Okay, we need to look at the problem though. We're supposed to have points to plug in order to find k and c. The points are here, they're just hidden. Okay, since it says it cools from 100 to 90, this is the temperature at time 0. So write this down, T equals 0, Y equals 100 degrees. So what would the second ordered pair be? T equals what? 10. Y equals 90 degrees. Agreed? So I have my T equals 0. That's the one I want to plug in first because it gives me nice numbers. I'm going to change colors just to make life interesting. 0, 100 gets plugged in first. 100 equals CE K times 0 plus 60. E to the 0, that's going to go away. Move the 60 over. C equals 40. Are we good with that?
Oh, yeah.
So now write the formula with the C in there. 40 EKT plus 60. One step closer. Now we plug in the other point, 10 comma 90. So 90 equals 40 E K times 10 plus 60. Okay, this is pre-cal, just solving equations. What do we do first? Move the 60 over. Just do it in your head. 30 equals 40 E 10 K. Agreed? Now what? Divide by 40. 30 divided by 40 is 3/4. Equals E to the 10K. ln both sides. Bring down the 10K. And divide by 10. Store it in your calculator. ln 0.75 divided by 10. Whoa. Why is it negative? Because it's cooling. It should be negative. If it's cooling, it better be negative. If it's not, you made a mathematical error. So store this for capital K. That way I don't have to write it anymore. So now back up here. Y equals 40 E capital K T plus 60. That is the particular solution for this problem. Okay, now the question said, what? How much longer till it reaches 80? Where does the 80 go? Y. So 80 equals 40 E K T, capital KT, plus 60. You finish it. I'm going to be handing out the homework papers, then I'll come back and finish it up with you. Do the math. I don't want to talk about that just yet. See when people catch it. Probably for tea.
Hey, make sure you can just plug that into the graph, right?
Good. Yeah.
It's right answer, but I don't know if it's
Okay, I'm just going to write up here because you guys have already done this. So ln 0.5 divided by k. Whoops, not that. Whoa, what did I do? Oh, I didn't store my k. Darn it. Store alpha k. 24.094 what? Minutes. But you know what? That's not the answer. Why is that not the answer?
It wants temperature.
It says how much longer. This is how long it takes from time 0. 10 minutes have already gone by. So we need to subtract 10. 14.094 minutes longer to get down to 80 degrees.